Okay, Geometry, Chapter 2, Section 3, Postulates and Diagrams. Apologize, I got a little sinus blockage going on, so I might sound just a little bit different. Interesting word there, postulates. Um, Kind of intimidating, but postulate is just a statement of fact. So I'm going to draw a diagram, and I want you to take this diagram and tell me everything that you know from it. So let me sketch it real quick, and I'll be right back. Okay, so now that you can see the diagram, you'll want to go ahead and hit pause and then create it on your own. Now that you've unpaused, we've got a lot of things going on here. We talked in the previous chapter about points, lines, planes, things being collinear, things being coplanar, things being vertical, and different relationships. So now what I want you to do, and I'm not going to list all of these because there are quite a few, but we'll just discuss some of them. I want you to go ahead and hit pause and tell me everything you know to be true in this particular diagram. Okay, so maybe you've unpaused it at that point. All kinds of things going on here. If you look at page 77 in your textbook, this is actually exploration number 2, and look at how many different things there are. All of the points are coplanar. This is one giant plane, so everything is coplanar. Points D, G, and I are collinear. I didn't draw that very well, did I? D, G, and I should have been slid over just a little bit. My bad. Let's take I and move him over. There we go. So I could draw a line through and get through that. Obviously, B, C, and D are collinear. E, F, and G are collinear. A, C, F, and H are collinear. We have some right angles on there, so we have some things that are perpendicular. We have some vertical angles, so some things that are congruent. We have rays. Ray CA and ray CH are opposite rays. Ray CD and CB are opposite rays. FG and FE are opposite rays. So many things. And each time we make one of these statements, basically all we're doing is identifying a postulate. And so if you've got your textbook and you're looking at it, let's flip over to page 78. And you'll see that there's a list of the first 7 postulates. So let's take a look at those. Okay, I write really fast. So you'll see that 2-1 and 2-2 on the page are linked together. They're basically the same postulate, just talking from different angles. If you have 2 points, it says through any 2 points there is exactly one line. And then the line postulate says the same thing, it's just a little bit backwards. It says the line contains at least 2 points, which means a line could contain 2 points, 3 points, 5 points. It just has to have at least 2. However, through 2 points, there is exactly one line. These will be used as we get further and further into explaining different diagrams. So now let's go to 2-3. Okay, so 2-3 states if 2 lines intersect, and that's key because 2 lines don't have to intersect. They could be parallel. But if they do intersect, they will only intersect at one point. It is impossible for lines to intersect at more than one point. Again, if they intersect at all. So that takes care of 2-3. Let's look at 2-4 and 2-5. You'll notice that they have to do with planes. So here's our postulates about planes. The 3-point postulate just states that through any 3 non-collinear points, there exists exactly one plane, and then we flip that around, and that just states that a plane consists of at least 3 non-collinear points. Has to be 3, could be more, obviously, at least, so there could be 4, 5, or anything above that. Again, we will take these postulates and just prove facts in our work today. So let's take a look at 2.6. I'm going to go ahead and go through this one and leave it running. Okay, 2.6 is the plane line postulate. Okay, the plane line postulate simply states that if two points lie in a plane, then the line containing them lies on the plane. So if 2 points are on a plane, then I'm not going to write this, but then if you connected those 2 points, obviously that's a line, and so that line would also be on the same plane. So it just states that the line containing those 2 points okay, the line containing those 2 points is on the plane. So 2 random points sitting on a plane. If you connect those 2 points, they are also on the plane. And so that gets us to 2-7. And 2-7 is the plane intersection postulate. And what that says, this is basically our revolving door examples from the first chapter. So 2 planes intersect okay, 2 planes intersect at a line. So think of the paddle wheel, think of the revolving door at an airport or a hotel or someplace, a grocery store, whatever the case may be. They are going to intersect at a line. Okay, so now let's finish it up. Let's take a look at this example. I've got plane X, okay, plane X over here. And on that, I have got some information. So let's see if we can prove any of the things we've talked about. Can we prove the 2-1 postulate? Okay, the 2-1 postulate says through any 2 points there exists exactly one line. So I could look at BD, I could look at BC, I could also look at CE, even though they're not connected, I could connect them and make a line. So the 2-1 postulate is on this diagram, which means the 2-2 postulate will also be on the diagram. So now let's take a look at 2-3. Can we take our information and prove 2-3? 2-3 is if 2 lines intersect, then their intersection is exactly 1 point. So if line AC intersects with BD, it intersects at exactly 1 point. So yes, we could also prove that postulate. Let's look at 2-4 and 2-5. Again, they're connected. That's why I'm not writing the postulate twice. 2,4, through any three non-collinear points, there exists exactly one plane. And 2,5, a plane contains at least three non-collinear points. So we do have non-collinear points if we put these all together. For example, A, D, C, and E, those are all non-collinear points if I group them together. So they would also fulfill those postulates. And so that brings us to 2,6. 2,6, if 2 points lie in a plane, then the line containing them lies on that plane. And so let's say B and C. B and C are 2 points that are lying on that plane. And so BC, the actual line, is also there. So that is found. I think the only one I didn't prove is the 2,7. And that is because I only have one plane. So this will actually express all of them except 2,7 because I don't have a second plane there, my little paddle wheel or my revolving door. So that's about a little over 11 minutes. That is Chapter 2, Section 3, Postulates and Diagrams.